Today we're going to talk about factoring polynomials. First, let's look back at when we multiplied polynomials. If we can see some connections here, it's going to help us with factoring. Remember when we multiplied these two polynomials? We used a box method and we came up with this product. See if you can spot any relationships between these numbers and what we have in our final product. This last number, the constant, is just these two constants multiplied together. The middle term is those two constants added together. That relationship is going to help us to go backwards and factor. We're going to be given a polynomial like this, and we have to figure out what were the two factors. Are great for factoring polynomials too. Let's say we have x squared plus 5x plus 6, and we want to factor it. We're going to try to arrange this in a rectangle. So you can turn your different tiles different ways, so I might arrange some down here. And then I can fill in with these unit tiles. Once I've created a rectangle, the dimensions of the rectangle are the factors. So this dimension here, this is x plus 2, and this dimension here is x plus 3. So my factors are x plus 2 times x plus 3. Let's factor this polynomial. I'm going to use the area model to help us work backwards. Now this will go inside the area model. So remember how we filled it out when we were multiplying? We had our x squared here and our constant down here. These two boxes will have to combine to give us 9x. So let's see if we can do a little guessing and checking and figure out what two factors make this product. To get x squared, I know I have to multiply x times x. To get 20, there are a couple different combinations I could use here. So let's just try some numbers. 2 and 10. 2 and 10 multiplied give me 20. So let's see what happens. All right, let's fill in the rest of the box. 2 times x is 2x. X times 10 is 10x. Then if I were to combine this area, I would get x squared plus 12x plus 20. So that one didn't work. Let's try some different numbers. So I'm looking for two numbers that multiply to give me 20. They're going to have to add up to give me 9. How about 4 and 5? X times 4 is 4x. X times 5 is 5x. 4 times 5 is 20. Now we can combine everything in here. X squared plus 9x plus 20. That's the polynomial I wanted. As you do more and more of these, you'll get better and better at picking out which numbers will work. So if you're asked to factor this polynomial, your answer are these two factors. So you would say x plus 4 times x plus 5. Let's try to factor this polynomial. Let's get organized. Okay, so I'm looking for two numbers that multiply to give me negative 24 and add to give me 5. We know we'll have x's here. Well, in this case, we have a negative. So think about what gives you a negative product. It has to be one positive number and one negative number. So can you think of a positive and a negative that multiply to give you negative 24, but add to give you positive 5? How about 8 and 3? So which one should be positive and which one should be negative? Since I want them to add to give me a positive number, the greater number needs to be positive. Now let's make sure it works. X times 8, x times negative 3. and then let's combine everything in here. That's the product I wanted, so these are my factors. So be sure if you're writing your answer, you want to write the actual factors. X plus 8 and x minus 3. Let's try to factor this. We have x squared and a negative 64. So I know I have x's there. Now I'm looking for two numbers that multiply to give me negative 64, but what should they add up to? Well, in this case, that middle term is missing. We could say x squared plus 0x minus 64. We want these to add up to 0. Since I have a negative product, I know one is positive and one is negative. So what two numbers multiply to give you negative 64, but add to give you 0? How about positive 8 and negative 8? Here we'll have 8x, here we'll have negative 8x, and then the product of 8 and negative 8 is negative 64. If I were to combine all these, I would have 8x minus 8x, so that is 0x, and then minus 64. This is called the difference of two squares. It's an important pattern to notice. If you have two items that are squared and they're being subtracted, the difference of two squares, then the factors will be the square roots added and subtracted. Let's try another method called factoring by grouping. If I'm looking at this polynomial and trying to factor, I'm looking for two numbers that multiply to give me this last term and add to give me that term in the middle. Those two numbers are 4 and 5. So I'm going to rewrite this polynomial, but instead of 9x, I'm going to split it up and say 4x and 5x. I haven't changed the meaning, it's still equivalent. Now I'm going to try to factor each of these groups. This first group, I can take an x out of both of these terms, so I have x times x plus 4. In this second group, I can take a 5 from both of these. I can divide a 5 out, so I get x plus 4 again. And that's what we want to happen. We want these two to match. And then I make my factors by saying x plus 5 times x plus 4. Let's try to factor this polynomial, and we'll use two different methods. First, let's try an area model. Now we want these two to add up to 26x, but notice this time we have a 3 in front of x squared. That means I need a 3x times x in order to get 3x squared. That's going to affect what goes in these boxes. Now luckily 35 doesn't have that many factors. I can use 35 and 1, or I can use 5 and 7. It's all positive, so 35 and 1 probably won't work to get me 26. Let's try 7 and 5. Now remember, this 3 is going to end up multiplying whichever number I put here. So if I do a little guesswork, I can figure out, do I need my 5 here or here, and my 7 here or here? I want my 7 to multiply by my 3. So I'm going to put the 7 here and the 5 here. When I fill in the rest of the boxes, I do 5 times x to get 5x, and 3x times 7 gives me 21x. So inside here I have 3x squared, 26x, and 35. That means my factors are these dimensions, 3x plus 5 times x plus 7. Let's try factoring by grouping with this polynomial. Remember that middle term is what we need to add up to. We need to add to get 26. But this time, a, or this coefficient in the front, is not 1. So that changes what we need to multiply to get. To find out what you need to multiply to get, you want to multiply a times c, or that first coefficient times the constant. 3 times 35 is 105. So we're looking for two numbers that add to give us 26 and multiply to give us 105. Now we did this same problem up here, but if we hadn't, you could just test out numbers until you come up with two that work. In our case, our two numbers are 5 and 21. So we're going to rewrite this polynomial, but in the middle here, we're going to split this middle term. 3x squared plus 5x plus 21x plus 35. It doesn't matter which order you do these, you'll still end up at the end with the same answer. Even though it might look a little different in the middle, you still get the same answer at the end, no matter which order you put those in. All right, let's factor each group. In this first group, we can factor x, so we get 3x plus 5. And in the second group, we can factor out a 7. So we get 7 times 3x plus 5. So you can see again that these match, and that's the goal. You can rewrite this expression as x plus 7 times 3x plus 5. These two expressions mean the same thing because x would multiply both of these and 7 would multiply both of these terms. All of these are equivalent expressions. This is the factored form.